So, like you mentioned, I'm Erik.
I'm John Goulah.
And we work at Etsy.
So Etsy is the world's handmade marketplace, and we've grown quite a bit over the past few years. Because Erik wanted to.
And it was interesting watching Tom's talk because, you know, we're a little bit smaller than Google, just a little bit. And what was interesting is that so much of what he said, we're going to say the same kinds of things. There's a lot of overlap in what they've come to and the processes that we've come to as well.
So we've grown a bit. Last year we did a little over 300 million in gross merchandise sales, and this year we're slated to hit over $500 million. We have about 1 million active shops and over 11 million total members. And we do transactions all over the world in about 150 countries. And we have about 11 million items listed right now.
So one thing we value a whole lot is speed and agility. We want to get features out quickly. We want to make sure the site is fast. Speed applies to every level of what we do. So that's one of the big things we're going to be talking about is how we stay going quick. And another big part of that is how we stay fast with a very, very quickly growing team of engineers. When we say engineers, we count ops, we count developers, we count program managers. Anybody who can commit code and push it is an engineer in some way, shape, or form. But one of the other things that we run up against is barriers.
Yeah, there's tons of barriers that can possibly get in your way, and we wanted to sort of talk about some of the barriers that we hit and how you can work your way around them.
So a lot of what we're going to be talking about is the tools that we've built and that we use internally, and a lot of them are available on our GitHub page. We are big fans of open source and, you know, contributing back to the community that's helped us so much. And this talk is going to be a lot of what we've done and how we do it. It's not going to be a prescription, you know, this is how you have to do it, but it's what's worked for us, and if we can help you in any way or you can help us, we'd love to talk.
So if you like what we're talking about, if some of these barriers are too much for you guys to overcome, we're always hiring. Come talk to us. It's fun to work where we work. We're doing lots of fun things.
So speed, right? So like I said before, you know, agility in code and getting features out there. One of the main metrics that we track is how many deploys we do in a day. It's a whole lot. We average about 30 deploys a day, and that's somebody actually pushing a button, getting code out there to all of our members and all of our web servers. We're also talking about how long it takes from having an idea to having the code on a live web server. And we want that measured in minutes, not in days or months. We have things in place that make it so that, you know, maybe only one person sees it or nobody sees it. But a very big part of our process is having things live and getting things in that loop as quickly as possible. We also do things like bunch up deploys into, bunch of commits into deploys, and people join together, and there's a lot of communication and coordination that happens. Now, whenever you're building anything, you have to optimize for something or some things. You're always optimizing, whether you realize it or not. You may be optimizing for how fast something executes. You may be optimizing for how pretty something looks. You know, if you're building a bridge, you want to optimize so that doesn't fall over. What we asked ourselves at some point was, what if we optimized, instead of code speed or other things, what if we optimized for making the people making the software happy and making the ops engineers happy? Would that work at all? And what we found is that it very much does help. Our CEO, who was our CTO, gave a talk at RailsConf last year, or this year, optimizing for developer happiness, which is available online. And it's a lot of these same things that we're talking about, but at a much higher level. And this is a truism for us, and we think for everyone. You know, if people don't like what they're doing, they're going to do a bad job. And that also applies to if the processes that are in place are onerous and tough to deal with, developers will find a way around it. And instead of adding value to the business, they'll route around, and then nobody wins.
So like I said before, there could be a lot of barriers that get in your way, and I wanted to go over some of the barriers that we hit over the years and how we overcame these things. Now, these are some of the major ones that we came across. This is not an all-inclusive list. So everybody here has probably worked on something fun at first. You throw some code up on a website, it's small, you're having a good time pushing code up constantly. Maybe you turn this into a business, the site gets popular, you hire some developers, you bring in some managers, and they come in and they bring a process in that from their past, and they tend to slow things down. Things get a little bit less fun. And a lot of places I've worked, I've come in and I'm saying, why are we doing it this way or that way? And it was even like that at Etsy. I started a couple years ago, and we had many different repositories that were completely disjointed, but the code depended on things within each. And I said, well, why do we do it this way? And there was really no good answer. So what we did was we fixed it. We went and put things into a logical place and made things easier and kind of answered the question of why do we do it? Well, we'll change that. Now, fear. Some fear is good. You put a where clause on a SQL statement, that's good, double-checking things. But if you have too much fear, it's going to kill all your progress and forward momentum. You get some traffic, you start to freak out a little bit. You introduce a process, slow things down, no more fun. Thinking a site has to be perfect before launching it is something that can be considered a barrier. Basically, the way we handle this is we launch code dark, we do percentage ramp-ups, we do A/B testing, but we don't necessarily expect it to be 100% correct. Otherwise, we would never get code out at the rate that we are. We do use production as part of our iteration cycle, so we rely on some of the community feedback to tell us what's wrong. And believe it or not, Pixar does things in a similar way. They actually get their movies in front of users for early testing. They want to be wrong as fast as possible, screw up, not be afraid, and take risks. And it's ironic to me that they do it this way because they only have one chance to ship this movie in the end. But they have the same kind of iterative release cycle. And legacy. It's not just about code. It's really finally ingrained into the culture. It's the hardest thing to change. At Etsy, we had the same type of problem. We kept our developers separate from DBAs, separate from the systems team. There were these barriers in between each team, and we didn't have the communication. We used to have this middleware layer that made it hard for developers to write SQL so that only the DBAs could write SQL. And this was a real problem for us. And Ross, one of our engineers, went into the details of the middleware layer. It's called Scaling Etsy. What went wrong, what went right, and you could probably find it online. So that's just an example of where the culture can be a barrier for you.
So how do you do it? It's pretty easy, right? I mean, there's not that much that goes into it, and I'm sure all of you are competent enough to build systems like this. All you need is people talking to people. That's easy, right? No one's ever had a communication problem of any kind. You need to have the ability to rely on your fellow engineer or your managers or upper management. That's easy, right? No one distrusts anybody. All easy stuff. And by default, you have to have everything open and have people be able to get everywhere. No artificial barriers. No one here has any of those, right? You can get everywhere you need to get. You can procure machines, everything you need to do. You have all these things, it's very easy. And just constantly working on making it better. Is today better than yesterday? It's all easy stuff that anyone can do. But I'm sure everyone here has problems with some of these, right? Otherwise, you wouldn't be at a conference about system administration. You would be doing the things that you do, because these are all problems that everyone has in every organization. And none of those were technical problems, right? The technical stuff is the easy part, except when you're at Google scale. Bless you, Tom. The technical stuff is the easy stuff. It's the cultural and the social stuff that's hard. And that's kind of what we're talking about. We're talking about the tools that we've built, but ultimately it's about the culture that it enables. So just a quick stroll down memory lane. I started at Etsy in mid-2009, so there is no Etsy before that for me. And I'm going to compare how things were then to how they are now and give you a sense of how far we've come. Things were a little bit janky, a little bit dark, a little bit smelly. And they're a lot better now, much more high-tech, Things move very smoothly. Everything is great. Back when I started, there was, I went twice. There was, for every deploy that went out, which was every 2 weeks, there was one engineer or ops person who was the deploy master, who actually pushed the buttons and ran all the scripts and watched the logs. And now anyone and everyone can push, and they do all day long. Like I said before, we're pushing upwards of 50 times a day. That means everyone's pushing. We used to roll back. We push the code out, that one push master would push the code back, and they'd maybe watch some logs, and they'd roll it back because they weren't sure what was going on. And they'd say to the developers, I think this is broken, fix it. And then they'd bring it back, an hour later or so, a lot like the canary stuff. And they'd roll it back, and they'd go forward. And it would come back and forward and back and forward, and it could go on for hours and hours and hours. Very different now. When there's a problem, we don't ever roll back. We can't go back in time. Something may have changed. Some data may be writing somewhere else. So it's up to the person who pushed that code to push a fix. Essentially it's the same thing, but it's a different mindset in how we operate. You can only go forward. And like I said, with that back and forth thing, where you'd push and you'd see maybe there's a problem. There's one particular deploy that I was the push master of in August 2009. That was the worst day ever. The deploy took 12 hours. It was the most stressful day I've ever had. And now we're about as far away from that as you can go. We push all day, every day, except at night and weekends. Not for technical reasons, but because we want people to not be stressed out all the time. So we've come a long way, and we're going to talk a little bit more about how we got there.
So these are some of the things that worked for us. Now, Erik talked a lot about optimization. The question is, what do we optimize for? Like we said, developer happiness is a big thing. Code agility. We optimize for the now. We don't optimize for the distant future, and we don't necessarily optimize for 100% uptime. We know that we're going to take some risks, we're going to make some mistakes, and we're going to learn from them. But we do optimize for fast detection and recovery when we do make those mistakes. And that brings us to these two terms. How many people are familiar with these? Mean time to resolve, mean time between failure. Most people. And the way I like to relate these two terms, you can kind of think of it, an example is in the car world. So you have Jeeps, right? You're expected to push them to a breaking point. They're easy to fix, but they break a whole lot. And on the contrary, Rolls-Royce, they don't break very often, but when they do, it's very expensive, very hard to find the parts, very difficult to fix them. So we're optimizing for recoverability instead of blindly chasing uptime. We're basically the Jeep if you relate it to the car world. We're optimizing for the quick resolution. Another big thing is access. So how many people here do not have access to their production systems? System administrator conference, so it's a lower, either you're lying or it's a lower number than normal. That's okay. But we believe it or not, I don't know how many people this scares, but we give our engineers access on their very first day to production. Doesn't necessarily mean we give them root, but we want them to be able to log in and look at things and diagnose things the same way anybody else would. So SSH access to tools like cacti, graphs, across the board, we want to default to open. So like I said before, the code part is pretty easy. You can write a tool like we have, Deployinator, or use ours. It's out there, open source, in a few days. The hardest part is the culture part, and it's really about communication, trust, and openness, like Erik said before. Convincing people, like your managers, to buy into this and agree with you that this is a good thing to do. So one way we get developers over the fear is your first day at Etsy, you have to deploy code. And this gets people kind of into the process that we have, gets them over that fear, and they understand that we are very quick to iterate, and you need to be pushing code pretty much all the time if you can.
So like the title of the talk says, we try to be dumb. Our CTO has a saying that we work hard to be this dumb. We use dumb as a term of endearment. We try and do the dumbest thing that's going to work. We try and get version 1 out the door as fast as possible and then find the problems. When we're sitting in a room imagining everything that can go wrong, and trying to build this huge system over months and months, we find we make a lot of mistakes, and we push it out, and we have a whole bunch of new problems. Whereas if we had the code out there right away, even if it isn't the final version, even if it isn't as slick as we want it, we hammer out a lot of problems a lot more quickly. We also have realized that most of our assumptions are wrong most of the time. And production disabuses you of your assumptions very quickly. So we do the dumb thing always. We're going to show you some examples in a bit that you may say, wow, that's really dumb. And that's kind of the point. When we're starting a new system, we say, what's the easiest way to do this? What's the cheap way to get it done? And then, if that falls over, then we make it a little better. We don't try and plan too far in the future. One of the things for working in this dumb way is we commit to a single central repository for our main application. We have a few different services and things, but we keep things clumped together. And for the main PHP stack, we commit to trunk or master, and everybody does. And not only do we commit to it, but we deploy from it as well. We also do our branching in code. Most source code systems were built with shrink wrap release software in mind, even Git. And what we've found is that doesn't give us the flexibility that we need to make certain things turn on and off. Here's an example. Like I said, the dumbest thing that can possibly work is an if, right? Check the configuration variable, do the new one, or do the old one. And that's it. It's as simple as that. So we don't branch in our source code. We branch in our code. We don't have long-lived branches where somebody's going off building something. I keep repeating the same things over and over again because that's kind of the point, is we want everything where everyone can see it and no one's off on their own doing crazy stuff. And as part of that, kind of a generalized version of that branching, is that all of the configuration is in the code. Right? We have all the configuration for the application is in the code. We use Chef for our configuration management of our servers. We have a bunch of other things going on. But for the code base itself, you have your configuration variables. Is this thing turned on? What ramp is this turned up to? Those kinds of things. And if you can picture in your mind the dumbest way you can do that, probably wouldn't be too far off from this. Right? We just have a big file with a bunch of variables in it. And we can actually just change those. We have an interface that we can deploy just the configuration. And that's all fine and good. The other big part of this is what to do when something goes wrong, how you recover and how you make sure things don't happen again. And that comes into postmortems, right? So we're working very fast. Something breaks. We fix it. And we could just move on from there and just be done with it. But a very big part of this is closing that feedback loop and figuring out what went wrong as best as we can and making sure it doesn't happen again. John Allspaw gave a talk at Velocity and then again reprised it at Etsy a couple weeks ago called Advanced Postmortem Foo and Human Error 101. And it's a fantastic talk, and I think the slides are online and maybe the video now. And the crux of it is that there's rarely a single root cause, and people's memories are faulty. So having a lot of monitoring in place and having systems that people can rely on for how to recover from these things are key to being able to move at this kind of speed. And one question we get all the time, so we address it in the talk instead of at the end, we treat databases differently. A lot of how we determine if something is part of the deploy or if it's part of configuration management or somewhere in between is rate of change. And our databases change at a slower rate than our code. So we do our database changes once a week, and there's a different process in place for those. It is still very agile, but it is a different process.
So another question we get a lot is, does it work, or how does it work? And the answer is yes, it does work for us. And I'm going to show you a couple of examples of how we make it work. The bottom line is that we use lots of graphs. We graph everything. Hopefully people are used to doing that here, and there's lots of great graphing tools out there. One of the things that we put on our graphs, and we have this patented vertical line technology. So when we deploy, we actually know when we deployed, and we can correlate that directly on our graph. So it becomes really obvious when there's a problem. In this particular graph, you can see a deploy caused the problem. We tried to fix it with another deploy, and then a little later actually did fix the problem. This is about 3 a.m. at night when we were moving to Git. Very fun. Another example of a quicker MTTR here, a quicker resolution, we deployed a config change that actually, if I'm not mistaken, broke registrations for a small amount of time. Pretty obvious, lots of alerts going off. Deployed another config change, and everything's back to normal. Now, one thing to note here is the blue lines are the config changes, red lines are web pushes. We have different color lines to indicate different types of change. Another example of a graph here, this is, if I'm not mistaken, memcache connections, and we were getting tons of failures. Actually, these are memcache connection failures. A few things I wanted to point out about this graph is that we use Sketch a lot to kind of point things out. It makes it really easy to just post graphs for people and say, here's what happened. Another thing that I think is really cool is the stat graph that shows kind of all the servers in a cluster. And we actually patched Ganglia to do this. We need to get that patch donated back, but it's very useful for us to see certain bits of change across the cluster. Is there anything else? You added this at the last minute, so I wasn't sure. In 2010, we only had major six change-related incidents. Now, compare that to 2009. We had planned outages every 2 weeks. Planned outages. Now, we're deploying code all the time, and we have much less major failures, and that's because we're pushing very small changes. So we're moving at a faster pace, and we have less downtime. We're a retail site, so we have this thing called a slush period. It's not quite a code freeze, but we slow things down a little bit. A lot of sites do have a full code freeze. We consider that we slowed down a lot too. Only 949 deploys in the month. Kind of bummed that we didn't hit 1,000. It's a retail site, so we're still taking risks even though our traffic is going up and up.
So just a quick discussion of a tool that we've built that enables this for us. And it's called Deployinator. It's open sourced. You can get it off of our GitHub. It's basically a very simple tool that we use as kind of the water cooler for us to come together and enable the communication and enable a single push button access to making the deploys happen. Here's what it looks like. It's not very fancy. It's pretty, but it's not very fancy. There's a bunch of buttons there. You push a button and you see what happens when you push that button. You see the code that's happening. You see the scripts that are getting run. You see a progress bar. But ultimately, you've just pushed one button and you're watching what happens. And the little box there, we could have hidden it and it could just do what it does and it's totally opaque. And that's great from an abstraction standpoint. But like we've mentioned, we want everyone to be able to see what's going on. So you can just watch that box, and if there's an error, you'll see it happen. That's also saved. But most of the time, you don't need to care. And since it is just an abstraction, we get to change what happens when you push that button and make it faster, make it better, make it more reliable. Now, we try, like I said in the beginning, to use open source wherever possible. And we're not the first people to invent a deployment system, so why didn't we use something that was already there? There's a lot of tools out there. And we didn't use any of them, right? We investigated a few of them. I've used Capistrano for a very long time, so why didn't we use that? It ultimately comes down to there wasn't a button, right? We wanted that abstraction, a web page with a button that you push and code happens. Every other tool out there requires too much of knowing how the sausage is made without having to not worry about it. So that's why we built it. A lot of it goes back to a book that came out in 2006 called Building Scalable Web Applications from Cal Henderson, who was at Flickr at the time. And in it, he says you need to have a push-button deploy. And we thought this sounded like a cool idea, so we built it. What we didn't realize was all the benefits we'd get from it in addition. With the logging and the monitoring and the communication, a lot more came out of it other than the ability to just push a button.
So one way to think about this, or one way we think about this, is it's a cockpit for understanding deployment in your environment. You go to a page, you push a button, everybody knows where to go, everybody understands that. underneath, it's just a series of rules, more or less shell scripts, really wrapped in Ruby. They don't need to know what's happening. We can change things underneath without people that are pushing that button all the time necessarily knowing, but we're happy for people to know. The more you want to know, the better, but we're abstracting that so that people can get their work done and just get their code out there. So
we totally stole the slide from Tom, by the way.
We coordinated. So it's just simple for people. It's just a bunch of Unix scripts wrapped in Ruby with a shiny button on top. You push the button, code goes out, simple stuff. So one example of how we iterate over our process and improve things constantly is now when you push the button, we kick off a set of tests. It's part of our continuous integration. And the tests come back and show the status in the Deployinator UI. Now, the important thing, though, is we don't have failing tests actually block the deploy. If somebody's crazy and all the tests fail and they still want to push the button, they can. That there may be repercussions. Most people don't. But we don't tie them together to that extent. But we do have certain things trigger certain events. So like the button kicking off the test is a good example of that. And then how do we communicate? This button is really a water cooler for people to come gather around and talk about the code that they're pushing as they're getting it out there. And the simple answer is we use IRC. We get into a channel. We have what's called the push train, and we use the IRC topic for people to kind of hop in line. People can bunch up into groups to deploy sets of code together. And again, another example of iteration is we wrote this little bot called PushBot that kind of helps facilitate that coordination. So it helps kind of alert people that it's your time, it's your turn in the queue, you're ready to go, it's your turn to push the button. And it helps us kind of facilitate that communication. But in the end, it's a human thing. Like people still have to talk to each other. People have to watch the graphs in the end.
We're going to change topics completely and talk about communication now. One of the things we use, we're talking about Deployinator. A big part of Deployinator is this enabling of communication. And I'm going to zoom in on a few things here in Deployinator and show you what we're talking about. So again, here's just what Deployinator looks like. We're going to zoom in on the button down below where you actually push to production. And you can see it's just a button, but there's links above and below it, right? And if you think about it, you're going to look at the links above it before you push and below it after you push. So let's look at the one before it. Those look like funny strings. They're just git SHAs. So what changed in this change? You click into it and you can see a diff. We actually use GitHub internally, but before we did, when we were on SVN, it looked very similar. We just stole their layout. And it shows you the commits that are in there, but more importantly, it collapses all those diffs into this is a single diff of the bits that are going to change on the server when this button is done. And those links stay around forever, and they get linked to these deploys. So when we see a vertical line that caused a problem, we can go and look at the exact bits that changed on all the servers, so we have an idea of what went wrong. It makes finding problems easier. It also is a very good heuristic to say, this is kind of a big change. Maybe we should split it up and put it out a little bit slower. And then afterwards, we have a link nicely named What to Watch. And that links us to lots and lots of graphs, right? We graph everything. Things that are insane to graph, like number of cups of coffee available. And the kind of downside of having the graphs is it makes it hard to know where to look when you have a problem or when you want to figure something out. So what we've done, what a lot of people have done, is we've taken those important graphs and we bring them into a single place called a dashboard. We've also just open sourced, or not just, about 4 months ago now, we open sourced our dashboard framework. We didn't open source it for a long time because we were embarrassed with how stupid it was. It's just a few lines of PHP. But people kept asking for it, so we open sourced it, and people are using it. It's the dumbest thing that can work. It's just basically a nice way to wrap up graphite, ganglia, and Nagios graphs and cacti graphs into a single page. This is an example of one of the dashboards. This is part of the deploy dashboard that you watch after a push. And you can see what deploys went out. You can see if things broke, how things are doing. They update in real time, so you can watch them for a few minutes after your push and see what's going on. And then another part of that communication is what Deployinator does. Like John mentioned, we're in IRC for communicating, coordinating the pushes. Everyone in the company is on IRC. Everybody. CEO, the receptionist, everyone at all times is on IRC. That's how we mainly communicate. And as part of that communication, we have a bot called DevBot, which is controlled by Deployinator. And DevBot tells us the important things about a push. Who did it, what went out, when they did it, and how long it took. And the how long it took may not sound so important, but it actually is a good feedback loop for the dev tools team to make the deploys faster. Because when people start noticing that deploys are slowing down because maybe we added a whole bunch of new boxes, they get upset because they can't push as much. So we have this feedback loop with having everybody be able to see everything. We can make things better for everybody.
So I'm going to talk for a second about how we actually run the deploy, what happens behind the button. Just so you know, there are lots of ways to do this. If you use Deployinator if you pull it off GitHub and use it for your organization, you don't have to do it this way at all. It's not prescriptive. The beauty of it is that you can code your deploy however you want. But since the topic of the talk is basically
It's web.
Huh?
Just that it's web.
Yeah, this is our web stack. There are some other stacks. Good point. So I'll get into it. And the point is that this is very simple stuff, the way we do this. And we're at a pretty decent scale, and we're still using fairly simple tools. So it kind of looks like this. We have one box that runs Deployinator. One box is our deploy host that we actually pull code from. And then we have a set of webs. So first step is that we SSH through to the deploy host to run various commands, such as cloning the repository or what have you. We're using tools that have been around forever, like SSH, things that people are very, very familiar with here. The deploy host issues a command using DSH. Everybody's familiar with distributed shell or something similar. There's lots of different ways, commands that do the same thing, but essentially it's fanning out to sets of boxes and issuing another command that pulls the code back via rsync. Simple stuff, things here everybody's used to using, I'm sure. So this is how we do it. This is how we deploy to hundreds of boxes, over 30 to 50 times a day. We don't yet need anything like BitTorrent. It's really simple, and the process works for us.
So another question we get all the time is, that's great. You're using an interpreted dynamic language. It makes sense that you can deploy it like that. It's built into Apache. You can just hup it, and everything's great. How does it work for other things? Does it work for, say, Java? Does it work for, compiled code? Does it work for anything else? And we've managed to use Deployinator for a lot of different things. When it comes to deployment, it is our hammer, and everything looks like a nail. Since it is just Ruby wrapping some, shell scripts, basically, we can do anything you do on the command line, we can do through Deployinator. We use it for our Solar stack, which is Java, Lucene, Solar, and it bundles it up in a jar, pushes it out to some servers, makes sure they're okay, pulls them out of the pool, slowly rolls it out, which is a very different kind of worldview than our web deploy. But the key part is that anyone on the search team deploying pushes one button. That's all there is to it. So that's cool, it's all standard web technologies, but what about something a little bit fancier? Can we do it for an iPhone? Right? This is something that we wanted to work on recently. We released an iPhone app not that long ago, and what the iOS developers found were they were getting really bored with how they had to keep pushing it out because they were so used to the web stack and being able to just push a button and have it go out that we figured out a way to do the same thing. And this is just another example of something we've come up with. Deployinator is used for internal tools, all kinds of stuff. But for the iOS stuff, it's Deployinator, and it actually shells out to a Mac Mini that then runs the build commands, which then makes an API called a test flight, which then alerts all of our testers that there's a new build. And it's just an example of using simple tools that are already out there, leveraging third-party APIs, and doing the dumbest thing that can work. We could have built a much more complex way to deploy this. We could have built our own version of test flight. But instead, we used what was out there, so we can get it done faster and get back to writing code and get back to building systems instead of solving problems that have already been solved.
So if this sounds good, you should try it. You can do this too. The code part is pretty easy. You could use Deployinator. You can write your own tool, whatever. The hard part is the culture, convincing people, making change. And the way to do that is one step at a time, one small project or one piece at a time until you can grow and grow, and then it will become the de facto standard. If you can't get this done in your organization, come work with us. And
I spent a lot of time in the beginning harping on this. It's kind of a pet peeve of mine. A lot of developers, especially people just starting, don't realize that they're optimizing for something. And what that means is usually they're optimizing for having fun on what they're doing. They're optimizing for getting their hack out there. What we found is that it's really key to know what we're optimizing for. We have certain things that are more sensitive than others, and those have different optimization trade-offs than other things. And we try and stay aware of it, and we try and feed it back into the feedback loop. It's part of questioning everything and not being dogmatic about any of it. So for us, it's we want to optimize for happiness a lot of times. We want to optimize for agility, for speed. We want to optimize for recoverability. We don't want to optimize for a year from now. We don't want to optimize for 100% uptime because we know that's impossible and it will slow us down tremendously. And like I said before, we love open source software. You can go to our GitHub where you'll find our A/B system, StatsD, which is a metrics collection service, Logster, which we use for taking logs and turning them into graphs, our Mongo tools, a whole bunch of stuff. That was not what I wanted. So thank you. And we have time for questions, so head to the mic.
Hey, I have a couple of quick questions. First of all, I don't think you mentioned in the talk how you do the vertical lines on deploys for graphs, because that's pretty incredible.
So we do them two different ways. For Graphite, there is a function called draws_infinite, and basically we just ping Graphite when a deploy happens and just give it a 1 value, and every other time it's a non-value. And then we just say draws_infinite and give it a color, and it just draws a line. Then we take those data points. Graphite has a really nice way to export data as CSV. And then we actually use that in Ganglia as well. There's a v-rule. So you just do a v-rule. Vladimir, I don't know if he's in this room, has a great blog post on doing that for Ganglia. And that's basically what we do. We take those data points and just draw v-rules on everything.
Okay. The second question is, how do you avoid problems with this sort of continuous deployment thing of sort of corrupting data, like the sort of major bug that might be more difficult to fix than something that's transient, like getting ugly data on a disk or in a database? How would you recover from that?
I mean, the short answer is it can happen, but the one way we do that is launching code dark. So getting it out there, ramping it up to people that work at Etsy first, having them test features. Of course, this is after it's fully tested in development. So unit tests, certain tests are written in development too. But the short answer is that we slowly ramp up code. So the employees get it first, and then we'll start with 1%. And slowly go from there. So that typically will avoid it. Do you want to add to that?
Yeah. So another key part of it is one of the limitations we put on ourselves is that we treat databases differently. And like I said, the schemas have them once a week. So that means your code needs to be able to handle both versions of the schema, right? And we have a config flag that says use old schema or use new schema. So the code works with both. And if there's a major problem, we just flip the flag back to the old way. Then we fix it, and then we fix it back over. We also do things like teed writes. If we're changing the way we massively change the way we write data, we'll write to 2 different places. And once we're fully confident that the new way works, then we cut over.
Thanks.
Hi, Paul Krizak from AMD. Wondering how you guys do major changes. I mean, deploying many times a day, it's great if you're tweaking this little algorithm, or you're changing the the logo or something. But what happens when you want to schedule a major change that ordinarily you would do with something like a branch, where you'd have like a bunch of development happening in the new version and then eventually cut over to it? How do you handle something like that?
So I'm gonna steal a line from Erik Reese. I think it was him. It's that a release is a marketing term. You know, the code is out there and has been out there for a long time. When we are releasing something, when we're turning it on, we're just flipping a flag and then it's live for everybody. So the code has been there, it's been tested, it's been run through Etsy employees. Nothing happens off in a branch on its own. It's behind some flags, you know, sometimes tens of flags for a big feature. And we'll roll it up slowly. We may roll it dark so that everything's happening, and then we just take the output and throw it away, just so we know that things are working. And then when we turn it on, you just see a new thing for the end user. So it's a completely different mindset from the kind of, you know, a team goes off on their own, builds it in a branch, and then releases it. You know, we roll it out slowly, and then what the end user sees as a brand new feature is kind of boring for us. Releases are very boring, and that's what we want.
And so then the developers then kind of have this culture of, they don't really do from scratch rebuilds of things. They just more work within what's already there, and then if they need to make changes, they make small steps in the direction they want, but not tear it down and start over.
Yeah, rewriting from scratch is something that we frown upon heavily. The big rewrite never works. That said, you know, we do brand new things, but again, we treat them as, you know, flags that we don't turn on until we're ready.
Okay, thank you.
Hi, David Williamson from Microsoft Hubby.
Hi, Dave.
First off, I admire your dumbness. It's brilliant. Could you comment a little bit on your current scale? You said about 100 engineers, but, you know, order of magnitude, number of systems?
Can we comment on that? Number of engineers is around 100. I don't know if we're allowed to comment on
Can we
systems.
comment on how many systems we have?
Let's say, I mean, I think I'm allowed to
Statistics?
say, yeah, about 500 to 1,000 right now.
Cool. And you're doing, you know, obviously dozens or hundreds of releases, you know, over a week or day, or you know, a week or a day, depending on load. Could you comment a little bit about scaling? Because it looks like, based on your IRC discussion and everything else, releases are serialized, and most of them looks like about a minute or less, but you know, it's highly serialized. It seems like, you know, I'm sure you aspire toward greater scale and more market penetration. If you were like, I don't know, Tom's scale, it seems like this would be kind of self-limiting and might be troublesome. Do you foresee a scale problem in the future, and do you have a plan for?
We saw a scale problem, and the scale problem we identified was doing things this way would scale to about 40 engineers, and it's gone way past that. Like I said, we don't optimize for the future. You know, we try and focus on the next 6 months, and we think our current process will work for the next 6 months. And as we go, we're going to iterate it and keep going. One of the ways we've mitigated is, like John mentioned, the push train and people bunching up on releases. And that lets us get slightly bigger chunks out without having much more danger and too big of a surface area. You know, there's lots of ways to mitigate that. You know, we shear things off as services every once in a while, very, very rarely, but that's one way of, you know, like the search stack is its own service, and that allows that to scale separately.
Yeah, it seems like there's a lot of optimizations possible. Do you foresee at some point like trying to do more parallel, you know, more parallel distributions, or?
Yeah, we did look at things like murder from Twitter. We've gotten pretty far with just DSH and doing fan outs of, what's our current fan out?
Something like 30.
30. And we've run into problems where the kernel on the deploy host can't handle as many connections as it's getting. So then we tweak that. And you know, it would be cool to do some really massively distributed parallel deployment system. That would be really fun, but we haven't needed to yet.
Right.
And as soon as we need to, we will.
Cool. Thanks.
All right, so I had 2 questions, and then another one just occurred to me, so I hope these are quick. As far as letting developers onto your production systems, have you run into problems with PCI or other financial audit requirements in that sense?
So I can't get too much into it, but we treat PCI differently. It's a different network entirely, and there are completely separate rules around that. The network that developers get on day one is not the kind of lockdown. A lot of the things we say can be seen as cowboy and no rules, and it's actually the opposite. We try and make informed decisions. We do have systems that are locked down, but we don't lock anything down by default. We look at the kind of trade-offs and we say, this needs to be a special case, like databases. We're going to treat it differently.
Okay. My second question was, does doing the dumbest thing possible ever get you into trouble? For example, you talk about branching in code rather than in your version control system. Do you not, at some point, then end up with big heaping plates of spaghetti that cause problems for maintainability in that?
Well, I think those two things are separate. So
Okay.
we do have big heaps of code, but we go and clean it up. So during that November slush period when we were deploying, not so much, we cleaned up a lot of our old feature that are completely dead at this point. We went up and cleaned up a lot of that code. Can you think of anything where it's bitten us?
No.
All right. And my last question was, you're deploying so frequently, and a lot of this code goes out dark, and then you flip a flag and the code goes active, at least for some population. Yep. Now, have you had problems where you flip this flag, which causes a problem, and now you've had so many deploys between, that you're not quite sure which one of them has actually caused the problem at the point that you change this flag? No,
because we have the vertical lines for config pushes as well. So we see when that flag was flipped, and then we turn that flag off. And we figured out what code was interacting with it. Like John said, we're optimizing for recoverability. And so we get it to fixed as quickly as possible, and then in the postmortem we figure out why it broke. And then we close that feedback loop, and we file bugs, and we figure out how to fix that specific thing.
All right, great, thanks.
Thank you. Are we out of time?
You have a couple of more minutes.
Okay, somebody had a question and ran off.
That was the last question, the same question.
Excellent. Any more questions?
So do you keep your config files under separate source control management?
Oh, that's a great question. Currently, no. We probably will at some point. Basically, what happens is it's inside the tree of everything else, and it gets pushed out. When we do a config push, it's just pushing that file to all the servers, which makes it hard to version that separately, and has.
It sounds like you'd have to if you're separately tracking those releases.
Well, you don't have to. It just is more work if you don't.
And we do track the version that's pushed out in a version.txt file or whatever, but it's in the same repository. So the version is just referencing a different point in that repo.
Yeah, our versions are the SHA in addition to the timestamp that it went out. So the config, during normal push, the config is the same version, and during config push, the config is slightly ahead.
Thank you.
Hi, I was just wondering how you manage the configuration of Deployinator. For example, if you're adding new machines or that sort of thing. Is that automated at all?
It's pretty simple, as most of our stuff is. We just use DSH groups. So when we add machines, we will just go and add them to that group. And that process could be a little better automated, but it's somewhat manual right now. So, if we add 10 machines, we just add 10 lines to the DSH group file. And then we have different groups for different services.
And it's another example of it would be cool to make a cooler system for that. That would be fun, at least for me. That's the kind of stuff I really like to do. That'd be neat, but we haven't needed to yet. As soon as we need to, we will make that a better system.
Hey, when you guys said Vladimir earlier, did you mean Vladimir Vuskin?
Yes.
Is he here?
He's at the conference. I'm
I think
surprised.
he's in the building. I think he's in the building. I don't know if he's in the room.
Best question I've ever gotten.
Hold on, I'll text message him.
Ah.
Cool.
Anybody else? Excellent. Well, thank you very much.
Thank you.